Hi, this is the second part of the notes from today. So this is relations and functions notes. We got through domain and range for discrete, but we need to finish with continuous. So if you didn't get the other notes from this, then go back to the previous video and check that out. This is just going to be kind of the tail end. All right, so we talked about discrete functions. Discrete functions, when you see them in graph form, they're just like a bunch of separate points. Continuous means that the points are all connected. So a relation or function is continuous if there are no gaps or spaces. So you should be able to draw your graph without lifting up your pen or pencil. Right? There's no gaps, there's no spaces, there's no jumps. Okay, that's what continuous means. And really, all the line represents just a ton of points, infinitely many points that are all just crammed together all through here. So there's actually infinitely many points super close together, so they're touching. That's called continuous. So we can't use a list here. If you think, when you're looking at domain, we want to look at all the input values and ranges all the output values. Before we used a list, but we can't use a list here. If you think about just the numbers between 1 and 2, there's infinitely many numbers in between those. There's 1, there's 1.1, there's 1.01, there's 1.0001, right? So there's like tons of numbers, infinitely many numbers just in between 1 and 2, which means that in our domain, if we want to say, from -4 to 3, there's not just -4, -3, -2, -1, 0, 1, 2, and 3. There's more than that, because 1.1 and 1.2 and 2.1, those all count as well. So we can't use a list anymore. There's infinitely many things in the domain. What we do instead is we use either an inequality or interval notation. There's two ways to do this. So if we go back to when we were talking about inequalities, an inequality has one of these symbols. Okay, less than, greater than, less than or equal to, greater than or equal to. So what we could say here is that the x values are going to be less than 3, but they have to be greater than -4. Okay, so that's how I write an inequality that represents this interval. It starts at -4, it goes to 3. Notice we have open dots here, and the open dots means not included in the domain. So all the way up to 3, but not including 3, all the way up to -4, but not including -4. That's one way to write the domain. Okay, now if we wanted to do interval notation is what we used when we did inequalities before. We pick the farthest left point, which in this case would be -4, and then we choose the farthest right point, basically the boundaries, left and right, and then we either use brackets or parentheses. We use parentheses when we're not including the numbers. So this looks like a coordinate, but it's not. This is actually an interval, and it means anything between -4 and 3, except not including 3 and not including -4. That's why we have parentheses here. So this is an inequality. This is an interval notation. All right. Now for the range, we can do the same thing. If you look at the y values, the smallest y value is going to be -1, and the tallest y value, the biggest y value, is going to be 3, including -1 and including 3. So notice, even though this point's not included here, we still have all these points here that are included. So -1 is the lowest we're going to get, +3 is the biggest we're going to get, and we're talking about the output values, the y values. So y is less than or equal to 3, but greater than or equal to -1. So if y is in between two things, you just actually literally put it in between the two numbers with a couple inequality symbols. So y is bigger than -1, but it's less than 3. It's sandwiched in between -1 and 3. In interval notation, this will be a -1, comma 3, but instead of parentheses here, we're going to use brackets because we want to include -1, and we want to include 3. All right, so there's 2 ways to write domain or range: intervals, or excuse me, inequalities or intervals. Okay, just as a reminder, the open dots means excluded. So we also use these symbols when we want to exclude something, and we use parentheses. So the open dot, the less thans without the line underneath, the parentheses, those all go together. So this is the symbols for excluded are these. If we want to include something, we have a closed dot, we have less than or equal to, greater than or equal to, so we have lines underneath that say include that number, and then in interval notation we have brackets that mean include that number. So notice that these symbols correspond to these brackets. This symbol without the line underneath it corresponds to parentheses. Okay, for this guy we also want the domain and range. So we look for all the possible input values, or all the possible x values. The smallest x I'm ever going to be is this -4. I'm never going to be farther than this. So this is my endpoint. So I know that x is going to be greater than or equal to -4. Okay. Now if I look on the other side, I have an arrow here. And this arrow means that this graph is going to keep going up and to the right forever and ever and ever. So there's actually not a limit. You're like, oh, well, my graph stops at 2. It actually doesn't stop at 2. The arrow means that it keeps going forever. So the biggest value that I'm ever going to get is actually going to be, I can't reach it. It's infinity. It keeps going. Okay. So I kind of start similarly to how I started writing this, except I get to this point, I'm like, oh, wait a minute, that's not a number? Okay, so if that's not a number, then I rewrite this without the number. So we get rid of this guy. And we just say, okay, so x is greater than or equal to -4. So this is kind of how I start. I always think, okay, x is going to be sandwiched in between 2 things. But if that one of those things is infinity, then when I write the inequality, I actually don't need the infinity. So this is -4 less than or equal to x. If I put the x over here, then the inequality symbol still has to be, like, if you think about this as like the alligator, this still has to be eating the bigger thing. So x is the bigger thing. For range here, I have something similar. So my smallest value is -1. So see that -1 there? That's the lowest it's ever going to be. And it's going to keep going up to infinity. So for my range, I could say y is greater than or equal to -1. Okay, now you could start writing it the other way and say, okay, y is in between. It's got to be less than infinity, but greater than or equal to -1. So you got your like left-hand bound, or your low boundary or upper boundary. But you actually don't need this piece with an inequality. So we kind of reverse it, and this is our range. In interval notation, the lowest point is, or the lowest value we're ever going to be is -1, right? We're never going to be lower than -1. We include that guy. And then the biggest value is infinity, because this keeps going up forever and ever. Okay. Sorry, we forgot to write the domain in interval notation. So let's go back and do that. So the smallest value is -4. The biggest value is infinity. And we don't include the infinity, but we do include the -4. Okay. So notice how this -4 infinity, that's almost kind of like what we have here. -4 is the low end boundary, infinity is the high end boundary for interval notation. All right, so on this last one here, now this doesn't have any closed dots or open dots, right, that we can see. But if it's a line, this connected line, every point on here is a closed dot. So you can draw closed dots wherever you want, assuming it's part of the line. So I can put some closed dots here to kind of help me out. Right, so for the domain, x has to be in between this guy and this guy. The smallest x is -1, the biggest x is 5. It's never going to I'm never going to have anything past 5 or past -1. So in inequality form, I'm going to have x less than or equal to 5, but also it's greater than or equal to -1. So we put the x in the middle. This is the low end, this is the high end. So this looks like -1 is less than or equal to x, but x is less than or equal to 5. That means x is in between -1 and 5. In interval notation, we're going to do 1, 5, and we'll put brackets because remember that if it's a piece of the line, then it's by default it's going to be a closed dot. Okay, unless you see an open dot there, then you know for sure it's not included. All right, now for the range, we want the lowest number to the highest number. Okay, so y, because we're talking about the input values, the y values, it's got to be less than or equal to 3, because that's the highest I'm going to be, or it's got to be greater than or equal to -3. So y is in between -3 and 3, right, somewhere in there. In interval notation, that looks like -3, 3 with brackets. Okay, so if we're including something in our range or domain, we need brackets. We need less than or equal to symbols, and that's represented on the graph with a closed dot. But remember, any point on a line is also a closed dot unless it's otherwise specified. Okay, open dots are excluded. We use parentheses for things that are excluded from the domain or range, and we use inequality symbols that don't have a line underneath, just a less than or greater than. For this stuff, independent and dependent variables, we didn't cover this today. We may get to it on the next lesson, but for now, we're just going to end here with the domain of continuous functions. So with this video and the previous video, that should be the examples that you need to help get you going on your homework. The homework is going to ask you some similar questions, and we've looked at examples for the different kinds of questions you're going to see for the most part. So I hope that helps, and I'll see you guys in class. Thanks.